Good morning, this is 7th grade math or course 2 from the Saxon math book, lesson 6. Our objective for today is what are factors and how can you use them? So by the end of this lesson you should be able to answer that question. So first of all, I guess what is a factor? The factor of a number are the whole numbers, which are those numbers 0, 1, 2, 3, etc. like that we learned about before, that divide the number without a remainder. So here's an example. Factors of 12 are 1, 2, 3, 4, 6, and 12. Because if I took 12 and divided by, say, 4, I get the answer of 3, and there's no remainder. If I divided 12 by 6, I'd get my answer would be 2, and again my remainder would be 0. However, these over here, 5, 7, 8, 9, 10, 11, are not factors, because if I took 12 and divided by, say, 5, I would get 2 with remainder 2. So I'd have a remainder if I had this one. So that means these are not factors. These ones are factors. So another way to think about it is like numbers you can multiply together to get 12. So for instance, 3 times 4 is 12. That means 3 and 4 are both factors of 12. So this is, let's try an example. This is an example like example 2. It's not example 2, it's like it. And let's just try this. An easy way to do this is to simply find two things that multiply together to give you 54, because our instructions say find the factors of 54. So what I'll do is I'll just draw a line underneath 54, and I'm going to start off with the easiest one that anyone can think of. I'm going to think of 1 and 54, because 1 times 54 is going to give me 54. Now I'm going to go up on the left here. I'm going to try to think of the next number up. The next number up from 1 is obviously going to be 2. I'm going to think 2 times what gives me 54. 2 times what would be 25, 26, 27. 27. Would be the next number up from 2 would be 3. 3 times what gives me 54? Well, 3 times 18 gives me 54. 4. Does 4 times something give me 54? Well, no, it does not. 5 times something give me 54? No, it does not. 6 times something, yes. 6 times 9 gives me 54. 7 times something? Nope. 8 times something? Nope. 9 times something? Well, yes. But notice we already have 9. 9 times 6. And so notice on this side, on the left-hand side, these numbers are increasing. They're getting bigger. 1, 2, 3, 6. Over here, these numbers are getting smaller. 54, 27, 18, 9. And notice we've tried all of those in between the 6 and the 9, like 7 and 8. That means these are all of my factors. So if it said find the factors of 54, I'm just going to list them out. The factors are 1, 2, 3, 6, 9, 18, 27, and 54. Alright, now that we know about factors, what can we do with them? Well, first one is to find the greatest common factor. And right now we're just going to practice doing that. We'll find implementation or how you can use that later. But right now let's just find the greatest common factor. Well, greatest just simply means biggest. Common means that all the numbers have, right? If we have something in common, something we both do. And then factors, well, we just talked about what factors are. So this is kind of like example 3. Find the greatest common factors of 12 and 20. So let's go ahead and just start off with that, and let's list what are the factors of 12. Well, if we go through that same principle, we'd have 1. Let's go and do this the same way we did it earlier. We'd have 1 and 12, 2 and 6, 3 and 4, and that's all of them. So those are my 6 different factors of 12. And I'm going to do the same idea here with 20, 1 and 20, 2 and 10, 3, nope, 4 and 5. So then these are my 6 factors of 20. So first let's look at the word common. Which ones do they have in common? I'm just going to highlight them here in yellow. Well, they both have that 1 in common. They both have that 2 in common. They both have a 4 in common. Anything else? 3 from the left is not on the right. 6 and 12 from the left are not on the right. And the 5, 10, and 20 on the right are not on the left. So therefore I have 3 what we call common factors. But notice specifically it doesn't say just any common factors. It asks for the greatest one. So the greatest common factor is going to be the biggest one of those numbers, which is going to be 4. So to answer that question, I would say the GCF of 12 and 20 is 4. Alright, just some terminology here. It says we say a number is divisible by another if it can be divided with no remainder. So just quick examples here. So 12 is divisible by 4, because if I took 12 and divided by 4, I would get a number with no remainder. Same idea here. 20 is divisible by 10, because if I took 20 divided by 10, I'd get no remainder. I'd get an answer. Or you could think about the smaller number is a factor of the larger. But I could not say 10 is not, well, I guess I could say this. 10 is not divisible by 7. So 7 is not a divisor of 10. Here are some handy tricks. They are on page 42 in your book, and you should probably copy them into your quick reference if you don't already remember them. This is a way to help you remind you, and you can reference them later. I'm not going to write them all out because it takes forever. I'm just going to verbally say them, and if you want them written out, you can write them out or read them yourself in your book, again on page 42. So a number, first of all, I guess I'm going to go to this green over here. I thought about, well, a number is always divisible by 1. No matter what number you want, you can always divide it by 1 and get no remainder. So here's some other tricks. You know a number is divisible by 2 if it's even. If it's an even number, meaning if it ends in a 2, 4, 6, 8, or 0. So notice this last number here. This last number here is a 4, and that number is even. Therefore, it would also be divisible by 2. We know it is divisible by 4 if the last 2 digits, in this case would be 1, 2, are divisible by 4. Since 12 is divisible by 4, then this whole number here would be divisible by 4. Same principle goes there for 8 if the last 3 are divisible by 8, and 104 is divisible by 8, and 8 times 13 I think is 104. So that means I would know again that the whole number is divisible by 8 if the last 3 are. We know it's divisible by 5 if the last number is either a 5 or a 0. So if your number ends in a 5, or if it ends in a 0, then it is divisible by 5, meaning 5 is a factor of it. It's divisible by 10 if the last number is a 0. Then you know 10 is a factor of that number. And these ones are kind of cool. 3 and 9 are quite similar in process. You know a number is divisible by 3 if, when you add up all of its digits, notice here I got 1, 2, 3, 4 digits, 1,836. If I added up all of those numbers, so think about 1 plus 6 plus 3, 1 plus 8 plus 3 plus 6. 1 plus 8 is 9, 3 plus 6 is 9. If I added those two up, 9 plus 9 is 18. Since 18 is divisible by 3, then this whole number over here is also divisible by 3. It's a pretty cool fact there to remember. You know a number is divisible by 6 if it's divisible by 3 and by 2. So if I apply the 3 principle here to this number, 1 plus 2 plus 6, that's going to equal to 9. Well, 9 is divisible by 3. And this number right here, the 6 is even. So since if you add up all of its digits, it's divisible by 3. And since the last number is even, the 6 right there, then this whole number is going to be divisible by 6. I hope that makes sense. And then the 9 is kind of like the 3. If I add up all those numbers, meaning if I say 2 plus 7 plus 9, it's going to be 9 plus 9, which is 18. Is 18 divisible by 9? Well, yes it is. Therefore, this whole number here is also divisible by 9. So they're kind of just some ways to help you remember or to figure out which numbers are factors of that. There's also a couple other things there in that box. It talks about if the last number is 0, it's also divisible by 2. If the last 2 numbers are 0, it's divisible by 4. And if the last 3 numbers are 0, then it's also divisible by 8. So just some things to remember there. Now, one more example here. It says, this is like example 4 in your book. What whole numbers from 1 to 10 are divisors of 234? So what I'm wondering is, what numbers